Hello, everyone, and welcome to Certara University Express Webinar Series. This is part 2 of our introduction to RsNLME, and today we're going to focus on activities we're up to around expanded workflow support. My name is Keith Nieforth, and I am the product owner for Certara's pharmacometric solutions, including Piranha, NLME, and Trial Simulator. And today I have with me James Craig, who is our R software engineer and RShiny developer. Just to cover a couple of webinar logistics, this is a 30-minute webinar with some time for Q&A at the end. All attendees are muted, and if you have questions, please use the questions panel in the webinar tool to ask questions. So today, what we want to accomplish is to just give a very brief recap of part 1 for those of you who may not have had the chance to view that, and then demonstrate our results UI RShiny application, which is an example of what we're doing to expand workflow support beyond the core analysis. So RsNLME, again, to recap, is a collection of R packages and companion RShiny apps that allow pharmacometric scientists to run models using Certara's NLME engine directly from the R command line. Our overall goal with this product is to offer a solution that combines ease of use with complete flexibility, provides expanded workflow support beyond the core pharmacometric analysis, and allows more users to harness the power of open source solutions, which are expanding every day. We recognize the learning curve for OS tools is steep, and our goal is to put the functionality and flexibility and efficiency into the hands of every users, not just advanced. We use a common modeling syntax that is Certara's PML, and that is consistent from individual modeling in Win-on-Lin all the way through to population PK at the R command line. And in addition, we are committed to actively and responsibly participating in the open source community to both leverage and help our users become proficient with the best tools. This is something that our IDD consultants have been doing for many years, and we plan to continue that. Ultimately, our goal is to provide a scalable solution that meets both individual analyst and organizational needs in terms of functionality, stability of the solution, and support. So to recap what was covered in part 1 of the demonstration, we went directly to the command line and set up an R session environment. We imported a data set, did some exploratory analysis, specified a model using some of the RsNLME functions in the packages, PK model, fixed random effects to set your initial estimates, and the fit model commands. We then ran some diagnostics by creating a expose database object from the NLME output using the expose NLME command, and performed VPC using the VPC model command and the tidy VPC package. So it was a good demonstration of essentially a core analysis. If you happen to miss that, the link to that presentation you see on this slide below, that's on YouTube. I'd like to remind everyone you can try this out for yourself. RsNLME, we're offering that free for academia. It's also free for current Phoenix NLME customers. And in addition, we are running a 1-month free trial of RsNLME and Piranha, and you see the link to register for a free trial there. So I'd encourage you to get a copy and try it out. Let us know what you think. In the last presentation, we covered the pharmacometrics workflow in terms of covering from data sources to final deliverables. And RsNLME can help move from a disjointed workflow using several different tools to a more streamlined workflow based on a foundation of R. Historically, users prefer to select and use the best tool for the job, tools they're familiar with, they know the capability, fit for purpose for specific tasks, leads to efficiency for that task. This approach works quite well, but does require frequent tool changes. And on the left, you see, I represent the tools as different fruits. Tool changes are often complicated by differences in syntax or languages, and this can cause significant overhead. It's not so hard to maybe translate a model. What's more difficult is doing the QC to make sure your translated model is actually predicting exactly the same as your original model that you may have fit to a data set. So you have individual task efficiency, but it's hard to be collectively efficient. In particular, unplanned iteration. So an unplanned iteration example of that would be, you have a good draft of your final report, you've generated all your outputs, and the clinical team comes back and says, you know what, we don't want to use the drug code, we want to use the proprietary name that the clinical team has just proposed. And now you have to go back through your report and change all of your drug names and figures that you may have generated from different softwares. It can be quite a tedious, resource-intensive process to do that. This is the nature of our work, however. In drug development, you only know as much until your next piece of data comes in. So it's important to be adaptive and flexible to handle situations like that. And this goes beyond report preparation. It's every element of drug development. Use of R and command line type flexible languages allow users to work more like you see on the right. Tools like R enable interoperability of tools without forcing integration. And while this entire workflow from really data pre-processing up to the final analysis can be executed from command line, what we've done with RsNLME is created Shiny apps to create models, edit models, explore and set initial parameter estimates, and execute models with various run settings, simple run mode, VPC, simulation, engine algorithm settings, this type of thing. So for key points in the workflow, we're supporting those with interactive tools that are based, again, on the foundation of R that actually generate code and teach users how to write R code, essentially. So today, we're going to focus on another UI that we're putting together, and this focuses on model diagnostics output and reporting to streamline that task. So why do we care about reporting? Often tools that claim report-ready output oversimplify what's required. And if you look at a typical clinical study report, most of our analyses go into some type of report. And this is not a document that's written by one individual, it's a team effort. And the effort is often managed by a regulatory documentation expert with their own domain tool sets. And these tool sets, the regulatory publishing systems, are designed to basically support submissions in different countries, organize large sets of documents, and adherence to the regulatory publishing format and content guidelines basically ensures quality and transferability of reports, among other things, between sponsor and regulatory agencies, within agency divisions, across national regulatory boundaries, and more. And in speaking to documentation experts who coordinate this work, when they receive components that do not follow template standards, it can take them literally hours to simply reformat. We're talking font changes, header styles, this type of thing, to correct these issues alone. So reporting workflow is important, not just for supporting the efficiency of an individual analyst to be able to do their work, but also if you look downstream, the full organizational task of, okay, where is this analysis going? It's going into a report. It's important to consider, requirements downstream in your workflow. So what we're going to demonstrate today is our results UI. And this is a sneak peek into the next release of RsNLME. Our planned release date is December this year, probably early December. And we expect to have a development version release available for anyone interested to take a look at it this summer. This will be again, an R package, easy to download and set up and take a look at. And essentially, the results UI is a continuation on the theme of providing intuitive use RShiny applications to support key workflow steps in the workflow and to expand workflow support beyond the core analysis for both individual and organizational benefit. So with that, I am going to turn it over to my colleague, James Craig, who is going to fire up a R session and give us a demo. So over to you, James.
All right, thank you, Keith. Let me go ahead and share my screen. Okay, so for those of you who are in part one, we'll pick up where we left off. We've iterated over a few models in the command line here. We started with a base model, arrived at a final model. We can take a quick look at our results here by simply printing out our fit job, the final fit job, and we're ready to generate the model diagnostics. So using the base model object and the final model object, which were previously executed here in our command line, we're ready to create our XPD database. And what I'm doing here is using the same command we saw in the last demo, this expose NLME command, except I'm creating a list of XPD databases for each model, starting with the base model and also for the final model. So go ahead and execute that. And we have the input ready for our model results UI Shiny application. So I'm going to go ahead and enter into this application using this function results UI, passing XPDB to the argument XPDB. And as you'll see, I've also assigned a return value to this, and you'll understand why here in a second. Okay, so as you'll see here on the left, we have a tree of model diagnostics, over 50 model diagnostics that the user can click on and easily explore their model outputs. And we can also switch between models with the same model diagnostic selected here in the tree to easily compare the same plot across models. You'll also notice various styling inputs here on the bottom. We can change the color of points if we'd like, increase point size, remove points entirely and just show lines. Also hide the reference line if we'd like. There's also more options to control the styling of the reference line. Show or hide our smoothing. Even change the span of the smoothing, as you'll see here, or the smoothing method. And even overlay text on the points. We also have various layout options that the user can explore. I'm going to go ahead and select a different plot to explore these. Go ahead and actually turn back our smoothing. As you'll see, we can potentially facet by a covariate of interest, gender, for example. Even change some of the axis inputs, such as logging the x-axis or y-axis here. Or control the arrangement of the plots. Here we're using the default arrangement, but if we wanted to stack this on top of each other in one column and 3 rows, you would just adjust that accordingly. Go back to the default arrangement. And here in the display tab, we also have further customizations available for the plot headings, titles, subtitles. Here, as you can see, we're using the default plot titles since default text is checked, but we can completely change the titles as we wish and make use of these tags from the expose package to dynamically change what our title would be by passing the X and Y values. Potentially, we may also want to customize various options related to font colors and size. So again, the Certara theme is checked by default, but if we'd like, we can show or hide grid lines, add borders, change the size of our titles. So a lot that can be done here in terms of how you'd like to customize these plots to the exact style that you or your organization sees fit. Going back to exploring the model diagnostics tree, we'll see that the plot type that's currently selected is scatter plot, which makes use of the various points, lines, reference lines, smoothing styles. But we also have various plots related to distribution. And as you'll see here in the UI, we have histograms, and the UI customizations have changed accordingly, where now we can specify the number of bins, overlay density, add or remove rug. So very flexible in how the type of plot interacts with the type of customization options available to the users. Now, I started with a base model. I'm going to go ahead and explore some of the model diagnostics that I'd like to capture in a final report, potentially, from my final model here. And go ahead and start tagging some of these model diagnostics. And you'll see what happens once I do this. If I'm interested in keeping this model diagnostic for a final report, I can hit this tag button, this floating action button in the bottom right-hand corner, hit tag, and there may be a couple others that I'd like to tag here. Let's do DV versus IPRED, DV versus PRED, and we'll also explore some covariate plots here. By clicking the covariate model, we can take a look at weighted residuals versus covariate. As you see, automatically the first covariate in our list is age, so that's the default selection. But I could also explore the relationship between weighted residuals and body weight, or a categorical covariate that I have in my model, gender. And again, since this is a categorical covariate, you'll see that the plot customization options have changed. Now we're editing options related to our box plots here. We look at weighted residuals versus covariate. We can see that we have a few outliers there. If we wanted to potentially make these more visible, we can go ahead and change the shape, the size. Red is a good color for outliers, transparency. So very flexible here in how you can interact with these plots, all from the command line, all from the Shiny application. And after tagging, you'll see that the code is actually generated for each one of my tagged model diagnostics. So I can actually take this back to the command line and reproduce this exact plot in my R scripting workflow. Also, these model diagnostics can be deleted here from this tag section. If we aren't interested in this diagnostic any further, we can go ahead and remove. And you'll also see that we have tables and user-defined nodes here in this tree. So something that we do intend to support in the future is on the roadmap for this application is the ability to generate tables, just like we're doing here for our plots, and style and customize them accordingly using the same customization window. And for user-defined functions, you can write your own function, specify that as a list into the model results Shiny application, and actually interact with your own functions here in this UI to visualize the results. I'm going to go ahead and tag one more plot here, and we'll show you some of the reporting capabilities next. So I've tagged 4 model diagnostic plots, and I'd like to get these into as a report. Well, what I'll do is go to this report tag. I'm going to give a title. You'll see that we have 3 file output types, HTML, PDF, or docx. I'm going to go ahead and use docx for this demonstration. We can adjust the margins and page layout accordingly if we'd like. And for my tag diagnostics, I can drag any one of these into this report output container, order them however I'd wish, and download the report. As you'll see here, my report has been downloaded. It's opened up in another window, but I have my model diagnostics here nicely formatted in my Word document, and you'll notice I initiated this document with my global template Word style already initiated. And it does not have to be a global submit template. It could be any style template that you wish. You just have to place that in a separate folder in the R package directory. And finally, in exiting the application, you'll remember that I assigned this return value, tag diagnostics. Well, so those tag diagnostics don't go away. We can actually interact with the plot object simply by selecting the diagnostic. And we have the plots available in our R session. And we can even take a look at the code. That was used to generate the plot, because the code is returned here in this list under the index tag diagnostic. And from here, you can potentially take this code and paste it back into your workflow, and you'll have this diagnostic ready for a complete reproducible script with the help of the Shiny application. All right, thank you very much. With that, I'm going to go ahead and turn it back to Keith, and we'll field any further questions.
Thank you, James. So that concludes our demo. Again, if you have ideas, suggestions, if you're interested in seeing a pre-release version of the results UI, please send me an email. Very happy to hear from you. And yeah, so again, we're working to expand the workflow support of the pharmacometric analysis beyond the core analysis. And as you can imagine, you know, if someone is interested in building a script that contains their whole analysis from start to the report generation, again, for the metrics component, that's kind of the direction we're moving in. So yeah, I will stop there, and we will take any questions. So Anna?
Yes, thank you, Keith and James, for this great presentation. We do have a couple of questions. The first one is, do you plan to integrate this functionality into Piranha?
Yes, definitely. All of the supportive GUIs that we've built with RsNLME are being integrated into Piranha. So certainly, you know, we're demonstrating the use of RsNLME from the command line. All of this is, you know, implementable through Piranha, and And it does make it easier for those who may not be super familiar with the R command line. So yes.
Great, fantastic. I have one more question, and if anyone has other questions, please type them in the Q&A panel. The next question is, are you planning to support any other workflow areas?
Yes, actually we are. We're, I guess, on the tail end of the workflow currently talking about report deliverables. But we're also building an application that is going to assist with dataset QC. So when you have at the very early stage of the analysis a candidate data set for your analysis, we are building an app that will essentially run some QC checks on that and give a report output on the data set itself. Yeah.
Great. There is one more question about, are these slides going to be available?
Yes, absolutely. Yep.
Yeah, we will make the recording as well as these slides available. Okay, so I think this is it for the questions that we have today. Thank you very much for the presentation, and thank you for attending.
Thank you very much. Have a good day.
Thank you. We will disconnect now.